Students, in this video we are going to solve problems related to the coplanar coplanar lines. I'll read the question now. Show that the lines r vector is equal to I cap plus j cap plus k cap plus lambda times of I cap minus j cap plus k cap and r vector is equal to 4j cap plus 2k cap plus mu times of 2I cap minus j cap plus 3k cap are coplanar. Also find the equation of the plane containing these lines. Actually here two lines are given. The line equations are given in vector form. In order to prove that these two lines are coplanar lines, we must know the drs and the point through which the first line passes and direction ratio of the second line and the point through which it passes. It is in the vector form. We know that when the line equation is in the vector form, the second vector form, that is lambda times of this vector gives us, this vector is made out of direction ratio of the line and this vector is made out of the point through which the line passes. So based on this information we can say that the first line passes through 1 comma 1 comma 1. The first line passes through the point whose coordinates are 1 comma 1 comma 1 and the direction ratio of the first line is 1 comma minus 1 comma plus 1, that is coefficient of I, coefficient of j, coefficient of k. In this vector gives us direction ratio and coefficient of I, j, k gives the point through which the first line passes. And similarly for the second line, here I cap is not there, hence we can consider 0 I cap. Hence the second line passes through the point 0 comma 4 comma 2 and the direction ratio of the second line is 2 comma minus 1 comma 3. Now we got the dr as well as the point through which these two lines passes. Now we can apply the condition that if we find out the determinant of this expression, if it is equal to 0, then we can say these two lines are coplanar. So we are just calculating it. We are substituting the values x1 y1 z1 and x2 y2 z2 the corresponding place and we are calculating the determinant. Finally determinant value is 0. When the determinant value is 0, these two lines are, as you know, coplanar. Now we need to find out the plane equation containing these lines. Hence we will use the formula, that is x minus x1 y, determinant of x minus x1 y minus y1 z minus z1. We will substitute those values here and finally we get the plane equation which contains these two lines. I hope you understand this problem. Now we move on to next question. The next question is find the equation of the plane containing these lines. So directly they say that we need to find the equation of the plane that containing these two lines, means we must use the formula x determinant of x minus x1 y minus y1 z minus z1. But before it we need to check whether these two lines are coplanar lines. This problem is exactly same as the previous problem we discussed. I hope you can solve this problem. Now we move on to next question. The next question is find the equation of the plane containing two parallel lines. Two parallel lines are given. We need to write the equation of these two lines, equation of the plane containing these two lines, and also find if the plane thus obtained contains this line or not. We need to check whether this straight line falls on the same plane or not. Still now we have used this plane equation x minus x1, determinant of x minus x1 y minus y1 z minus z1 a1 b1 c1 a2 b2 c2 equal to 0 when L1 and L2 are coplanar. Even though they are coplanar, they are not parallel. See this, the line 1 having direction ratio and passes through L2, they are non-parallel to L1c. Only for non-parallel lines we can use the formula. But if you observe this, these two are parallel lines. So we must use different technique to find the equation of the plane containing these two parallel planes. As you know, first we need to check whether they are parallel or not. Based on this, you know that it has to be converted in the general Cartesian form, that is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Right? Based on that information, we calculated dr and the point through which the first line passes. Similarly, for the second line, we need to calculate dr. For that, first we must find out the dr and coordinates through which the second line passes. So what we do is we calculated this. We assume that this value is we calculated dr of the second line and the point through which the second line passes. Now what we are going to do is, here we got 2 points through which it passes through. In case if we know one more point either on the first line or the second parallel line, if we find out one more point on any one of these, means already we have the point through which they say that these two are parallel lines. Parallel lines means definitely those two are coplanar. What we are going to do is, in order to write the plane equation which contains two parallel line, means what we try to do is we try to find out 3 points coordinates. If we know 3 points coordinates, we can use the formula that we already learned in the previous concepts. For example, when 3 points are given, means equation of a plane passing through 3 non-collinear points is given by this expression, right? We can use this technique. Already the plane passes through 1 comma minus 1 comma 0, this is 1 point, and the second point is 0 comma 2 comma minus 1. We know coordinates of 2 points. Now if we find out the third point, it will be convenient for us to write the equation of the plane. In order to find out the third point, what we do is we find out the general point on the second line. This is the plane equation and these are proportional. This equation, this value is equal to k, means general point on the second line can be written as, already we learned this techniques, 4k is equal to x, and y coordinate can be calculated as minus 2k plus 2, and z coordinate value can be calculated at 6k minus 1. We used this technique in point of intersection. We using that concept only, we are finding the general point on the second line, right? Putting k value is equal to 1 means we are getting another point on the second line. Now we got 3 points through which the plane passes. Then we can write the plane equation using the formula determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. When we simplify it, we are getting the plane equation. Now we solved the first part of this question. Find the equation of the plane containing two parallel lines. We solved this first question, and the second part is find if the plane thus obtained contains this line or not. That is what they say. What we can do is we can take the point through which the line passes, right? Here the line passes through 2 comma 1 comma 2. Definitely if this line passes through this plane, means definitely the coordinates 1 2 comma 1 comma 2 must satisfy the plane equation. If it does not satisfy, means this point does not lie on the plane. Using that technique also we can find out it. Let us check. 2 comma 1 comma 2, right? 2 comma 1 comma 2 can be substituted here and check whether this plane gets satisfied or not. But in the book they have used some other technique. They have used normal concept. The technique that I discussed can also be applied, but this technique can also be applied. The direction ratio of the normal to this plane, based on this plane equation, we can say coefficient of x, coefficient of y, coefficient of z is the direction ratio of the normal to the plane. So they say a1 is equal to 8, b1 is equal to 1, c1 is equal to 5. The given third line equation, direction ratio of the third line is 3 comma 1 comma 5, and it passes through 2 comma 1 comma 2. So if the line and this direction ratio of the normal and direction ratio of the line. When we solve it, a1 a2 plus b1 b2 plus c1 c2 equal to 0 means the third line is parallel to the plane. So third line is parallel to the plane means definitely this 2 comma 1 comma 2 is a point on the plane, hence the plane contains the third line as well. Using this technique also you can find out, otherwise the coordinates 2 comma 1 comma 2 can be substituted in the equation. We can check it. 16, I just substituted 2 into 8 is 16, 16 plus 1 is 17, 2 into 5 is 10, so 7 is equal to 7. We are getting the answer. We need not go through all these steps, directly we can substitute these steps, these coordinates. If it gets satisfied means the plane, the line must pass through this. I hope you understand these problems. With this, I am completing the video. In the next video, we will solve some important problems. Thank you students. Thanks for your cooperation.